Hello everyone, in this video I'll be talking about the electrical axis of the heart. So when we view the heart from the frontal plane, every direction of the spread of the depolarization wave through the ventricles is known as the cardiac axis, mean QRS axis, or the electrical axis of the heart. When we want to determine the electrical axis of the heart, we need to remember two rules. First one is two extremity leads that show tall or waves of equal amplitude. The mean QRS axis points midway between them. Second one is if there is an extremity lead that is showing biphasic complex, either QR or RS complex, the mean QRS axis points at an angle of 90 degrees to that lead. So let's discuss a few examples. In this example, you can see in the lead 1, you have a biphasic complex. So the mean QRS axis would be at an angle of 90 degrees to lead 1. Also in lead 2 and 3, you have maximum amplitude of R waves and that amplitude is equal. So the mean QRS axis would be projecting between lead 2 and lead 3, that is along the lead AVF. So mean QRS axis would be plus 90 degree in this case. In this example, you can see the biphasic complex in lead second. So the mean QRS axis would be at an angle of 90 to lead second. Also, since the amplitude in lead AVL is positive, so the direction of the mean QRS axis is in the direction of AVL, that is minus 30 degrees. In this case, you can see the biphasic complex in lead AVL. So the mean QRS axis will be projecting at an angle of 90 degrees to the AVL. And since there is positive deflection in the lead second, so the mean QRS axis would be along lead second, that is plus 60 degrees. In this example, you can see the biphasic complex is in lead 1. So the mean QRS axis would be projecting at an angle of 90 degrees to lead 1. And since AVR and AVL are showing positive deflections, so the mean QRS axis would be at an angle of 90 to lead 1 and between the AVR and AVL, that is it would be minus 90 degrees. In this example, you can see biphasic complex in lead AVR. So the mean QRS axis would be at an angle of 90 to AVR, and since you have positive R wave in lead 1 and negative waves in 2 and 3, so the mean QRS axis would be more towards the left side and at an angle of 90 to AVR, that means it would be at an angle of roughly minus 60 to the lead 1. Just by looking at the lead 1 and lead second, you can determine whether the axis is normal or whether there is left axis deviation and right axis deviation. So, and we call left axis deviation and right axis deviation any mean QRS axis between minus 30 and minus 30 and 100 is normal axis. If it is more negative than minus 30, we call it left axis deviation. If it is more positive than 100 degrees, we call it right axis deviation. And if it is between minus 90 and plus 180, we call it extreme axis deviation. So if in lead 1 and lead 2 both have positive R waves, the axis is normal. If in lead 1 the R is positive, while as in lead second S is has more amplitude than R wave, so it is left axis deviation. If in lead 1 amplitude of S wave is more than the R wave and D2 is showing positive R wave, that means it is right axis deviation.